Hi, I'm Tom Stephenson. Welcome to Construction Site Management, Lecture 2B. Hopefully you've gone through 2A because this is just following up and going a little bit more detailed into some of the things that we were discussing regarding the project manual and specifications master format. And we will also be just giving sort of a high-level view of the different types of drawings, the different types of specifications that you can run into on your projects, and then how those project documents are best used on site and in projects, right? So we're going to continue on with the master format. I'm going to do some comparisons, and then we'll break things down and sort of wrap things up. I don't think this lecture will be quite as long as the previous one, but it should give you a good sense of how things kind of go together. So we were talking about master format, and we were looking at the 50 division format, which is 0 to 49. We said there's some sections that are reserved, so for future that they can utilize those in. Whoever's writing specifications shouldn't be stuffing stuff in them. Typically, things that are out there now have their appropriate location, and if it's something that's really detailed that there's nothing to reference, that's what level 5 is, the last one. So typically it's going to go to level 3, level 4, but if there's something that doesn't seem to fit, it must have a category that would make sense under, and then that would come under level 5, detail. So just to give an example, earthwork would be division 31, and if we're talking about shoring of earthwork, that would be 3141. And then if we're talking about shoring that's using sheet piling, that would be division 31, 41, 16. And then if we're talking about steel sheet piling, sometimes you'll see steel sheet piling used as like a retaining wall, maybe for a dock or similar aspect to stop the movement of soil. You might have 31, 41, 16.13. Okay, so it's just detailing it out, and these are going in pairs, and that would be your level 4 if it's being specific on steel sheet piling. And if it's something that is really specific to the steel sheet piling that you're using, that's not got a place under 0.13, then you would make it user defined, and that's where you create whatever specific information you want about that. It's not that you're writing specifications, but it's just how, if it's been done under the master format process, how you might see it indicated using the hierarchy. But steel sheet piling would always be under this number, right? So it's always a defined number for those parts. So they'll have, under the 50 division format, they'll have a hard space between them. The 16 division format, they don't, but under the 50 division 0 to 49, they do. And as I mentioned before, and we brought up that document before that indicates standard numbers and how they're standardized and used. So this is using the old format, and as I said, there's no spacing there for grading. I don't think this is a true indication of the grading, but it makes for an interesting photo anyways. And we've got 1995 version. If you put it under the 50 division format, you're using the different numbers going down. Rough grading would be what we're talking about here. Okay. Another example would be domestic water piping. So under the old section, it'd be under 15140. And if we recall, plumbing got moved to section 22. So it's under section 22, 2211, and then domestic is under 16, so same issue, just it'd be different location. Just showing you how the two formats work together. Cast in place concrete, so it's still going to be division 3, so it's going to be in the same area. And if we are going to here, it'd be still under division 3. So you notice that all those sections that were the same, they are the same here as well. So it's really when you get into the specialty trades and the site conditions aspect where they separate out. In building systems, they definitely separate out. So cast in place and cast in place concrete, heavy weight structural concrete. So just detailing it out further and further detail, and that's MasterFormat 2004. And I think we got another one here. So section for storm drainage. What was that? That was in 2. So this is now into section 33, and it's under the site and infrastructure subgroup. So that's why they've got those groupings that you see on my earlier slides from lecture 1 that are posted, that the site and infrastructure subgroup comes under here. And so we've got storm drainage structures, and there we go. Also, I should mention, you're going to do courses if you're in the 3-year program. There's a cost control course in 3rd year. I may teach that, it depends, but in cost control, you have different sections, and you can utilize MasterFormat for coding. So you can use MasterFormat for cost codes, and so you'd have your project number that would be unique to your company that you've established, job number, maybe based on area, maybe a number based on the manager, project manager for the project, an identifier, right? So then you know that these codings are coming under that. And then under the MasterFormat, so we can assign coding under MasterFormat so it can be tracked for areas of work. And then if we budgeted from the MasterFormat, so estimators very often budget from the MasterFormat, and now you can track those budgets and assign those budgets cost codes, then you can see how you are matching up, and you can evaluate the work that you're doing compared to your benchmark. And if there are variances, then you can determine, why is there this variance here? How do we get that time back? How do we get that cost back? Or you can give feedback to estimating so that you don't keep making the same errors in future projects. So cost accounting and project monitoring are very important in projects, because we need to know how we're doing, and we also need to build up a good historical data database so that we can we can utilize it for future costings and for the continuous improvement aspect. This would be a distribution code, so this could be like, if this is for the subcontractors, is this for materials, particular resources to identify as well. But the MasterFormat part is just utilizing those codes for the areas of work, and those areas of work could be broken down in a budget that way. So just utilizing the code structure here. And because you don't see the spaces, then you realize this is under the 16 division format. So it's not under the 50 division format. So when we talk about construction documents, we have to think about the drawings. And you know, there are a lot of drawings that we utilize on a construction project. You may be familiar with the architectural drawings, and very often if you're in low-rise residential, there's just the architectural drawings, and you'll have like electrical outlets indicated and things like that. HVAC sub will do their own drawings. They'll submit for a building permit to the permit office. Electrical subcontractor may have to apply certain elements of that for their hydroelectric permit through the electrical hydro office. But in larger projects, commercial projects, institutional projects, condominium type projects, civil projects, you're going to have numerous drawings. You're going to have the architectural drawings, and you're going to have the structural drawings. You're going to have mechanical drawings. You're going to have electrical drawings. You're going to have landscaping drawings. There's going to be a number of drawings that would be required. And of course, a site set of drawings, site drawing, site plan that will show the location of the building, will show the property lines, will show the setbacks and all of that type of information, location of infrastructure, utility points, etc. So the drawings are an integral part of the construction documents, because everything in the specifications ties to what's on the drawings. You know, it's going to, specifications might tell you the details about the window units that are used. They might provide you details about the kitchens, cabinets that are going to be used. It'll tell you details about the structural steel that is to be used, etc. So really the specifications tell you information that won't fit in the drawings. You don't want to be putting the information that's in the specifications on the drawings. It's just going to crowd out the drawings. You're not going to see anything. There's already enough information on the drawings. So it's why we use abbreviations and symbols and things of that nature on drawings, and it's why we have the specifications to detail out the informations regarding the general information, the products themselves, and the execution. So we do have these various sets of drawings that we utilize, and if I can find it here. So we'll have our architectural drawings like these here. So this is for this condominium project example. And we have site plans, which is very typical that you're going to see a site plan right off. And then you're going to get into the various floor levels. You're going to have some details and some hatchings and reference points. All right, so schedules that are going to help you to reference different elements of the drawings. And you're going to have your various floor plans and elevation drawings, right? And section details. So this is the architectural drawings. This is not going to give you information about, you know, the rebar that's going in the concrete and the strength of the concrete. Those are separate, though that information is separated out into the structural drawings. So the architectural drawing is going to give you information about the sizing, the types of materials that are used, and the layouts of the rooms, and the parking, underground parking garage, etc. I go down a bit. So all the condominium units, all the information that's on those particular units. So that's going to give you that kind of information. The structural drawings, now you're going to get into, you know, the caissons, the depth. You're going to get in, there'll be related structural drawings that'll be required. So you will have your engineering drawings that will be a subset of this. But this is going to give you the main information that you need to do. If I'm basically the forming subcontractor, this is going to provide me the detail with regards to the structure itself, and this being a reinforced concrete building, it's going to provide me that information about the columns, the shear walls, the rebar requirements that are involved in it. So these have to coincide with these, so they have to work together, right? So you can't have this saying one size or information that doesn't fit the others. They have to work in sync with each other. And what works in sync with that also works in sync with specifications. So here we've got the structural specifications, and in this case, the structural specifications. So right off the bat, when you see the spacing like this, you're knowing, oh, okay, this is going to be the 50 division format. Look at that, it's got division 31. Oh, it's got caissons, all right? So that's going to be under earthwork, and that's the deep work, deep foundation work, so that's why that's there. Oh, concrete, it's still in division 3. Doesn't matter which version of specification I'm looking at, it would come under division 3. And you can reference these slides and the previous slides that we've looked at to remind yourself of what's in which one with regards to the divisions. You can also Google this information. You can get listings of the various requirements and information that comes up. So I'm just going to quickly, I thought I had the architectural specifications. So there's the architectural specifications for this project, so I just brought them up. And the architectural specifications, lo and behold, the architectural specifications, see how they're going? So they tell you what's involved, which divisions are shown. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's the 16 division format. So they're not including anything under these in these specifications because they're going to have just like they had with the structural, their own set of specifications. But they do have some information in here, but it's going to reference the structural specifications. So this is under the 16 division format, my point being, going back to the structural specifications. See, this is only looking at these, right? So there's no other specifications that this is looking at. These are what's being referenced here. And this is for the structural reinforced concrete work, drilled caisson foundations, as we mentioned. Here is the section listing up here, and then it follows under that general information for each particular area, right? And then there should be, if I follow it down far enough, part 2 for the products, and then there should be a part 3 for the execution. So that's very standard in how specifications are written and documented. It's kind of, I think it's actually kind of cool in these samples that it's showing you the structural is using the 50 division and the architectural is using the 16 division. Welcome to the real world. Sometimes I'll get a student, oh, why it should be like this and it should be like that. Well, there's different companies, and different companies use different structures. And if I'm an architectural firm and I do a lot of private work and I don't do much government work, so I do condominiums, and I've always used the 16 division format and I find it easy to use, then I'm sticking with it for now anyways. And if I'm an structural engineering company and I do reinforced concrete buildings, but I also do office buildings and I do government work, I have to have the 50 division format. Why not just do it in the 50 division format? And then that's how that comes out to play. So you got a little bit of background on the history and how these different drawings integrate. And of course, when you practice in labs and other places, this will come together and make a lot more sense when you're using it. But I think you need to know this background information to be successful at using it. So that gives a good understanding of how the construction documents fit together, because there are a lot of them. So you've got the specifications, you've got architectural specifications, you've got structural specifications, you have specifications for the specialty areas such as the electrical, the mechanical. You'll have the contract documents at the high level. So that's really giving sort of the high level view, if you're a GC, of what's required. And that includes then in the original draft of the project manual, you're going to have the bidding requirements, if it's an RFP type process, what the requirements are for that, and the general requirements for the contract. Then you'll have, if you're successful for the project and now you're constructing it, you'll be following the construction drawings, the approved construction drawings for the project. You'll be following along with your contractual requirements. That's at the highest level. Specifications take precedence next after the construction contract, and then the drawings next after that. And we just mentioned before in the previous lecture how the conflicts work. So these are pulling these together and seeing how the different areas have to work, and they have to communicate with each other, and when things aren't in sync, how there's a problem. When you have BIM, you have one 3D model, and you have to integrate all of these parts into the model, and then also be able to shed parts away so that different areas can view what they need to do and that it fits in the model. That requires extensive coordination as well. BIM is fantastic as far as making the projects go better when you're in them, but it does require a lot of upfront work, planning, and coordination to be successful, like anything. So we use the construction documents at pretty much every stage of construction, from pre-construction to layout. We use it to help clarify things that, if something, we don't understand something, hopefully it is listed out in the construction documents. And as I've mentioned before, we'll be talking about processes and how to elicit information and track information, how to submit for approvals, all of these elements that feed into the construction documents and the running and planning and managing of the projects in our coming lectures. But definitely all these documents help us, like we're going to have questions as we start to construct, and it helps to clarify what we want to do. It's definitely, the drawings are going to help us with regards to layout and where things have to go and the sizing of information, and the specifications are going to give us the details about it. As I said, they're kind of separate in what they're trying to provide us. That means one doesn't have to have the information duplicated, right? I don't need dimensions in specifications, and I don't need to know what kind of faucet you're putting in the actual drawings. So it gives us direction then. How are we going to construct the project? Because we can deconstruct it by looking at the project and seeing what's the finished project and how we're going to deconstruct it to build it. And then we can look at how that actually goes forward. What activity must go first? What's the next activity that comes after that? We'll talk a little bit about that when we talk about lean construction, because lean construction requires a little bit of different thinking. Traditional construction is kind of push, so we start at the beginning, we think this, then this, then this. Lean is kind of pull. What do I need to get this done? And so I'm pulling this information, and so there's a more even flow to our projects. If we can have a good, steady, even flow in our projects, we'll have a very efficient construction process. It can be helpful for us to develop checklists from this, and we'll talk about the value of checklists in another class. Compliance inspections, so we'll have good understanding of what the requirements are that we're supposed to meet. Again, commissioning processes, the test and commissioning of buildings to ensure that they meet the intended standards and they meet the intention of the original drawings and specification and contract are very important. And we use them to ensure that we're on the same page with things. As I said, when you're meeting certain test standards, like we talked about in the previous lecture, it's helpful. It's a standard. This is what we have to do, and this is what we have to meet. And if we meet that, then we're complying. It's very clear. It's not good when things aren't clear. In construction, things that are opaque, obscure are not good. Things that are transparent, that are easy to understand, that is clear, and nothing is perfect in construction, so we need to know what's acceptable tolerance levels. These are important things in being able to run our projects efficiently. And also making sure that we are effectively communicating, so it becomes even more important. And this is a vehicle for communication from the consultants to the contractors. It's a vehicle of communication from the contractors to the subcontractors to the suppliers. It's very, very helpful that way. It's also a vehicle of communication to the clients. Even though they may not have that expertise particularly, it is helpful to be able to explain and to communicate effectively. And we can also verify things, so we can check on things through this process, and we're pulling information from these documents to help us in the verification process, as you'll see when we talk about further documents like mock-ups and submittals and other areas. And if there's something that's missing, we can use an RFI process to help us. So when we think about familiarization, and the book does a very good job on a lot of these areas of getting much more in depth in it than I can cover in the time period that we have, but it has actually a very good area on the next few slides that I think is very helpful on page 64 and 65. I think it also goes through the whole drawing process very, very well. But like in 64, it talks about familiarization steps with the project, and the familiarization steps involve reviewing the site plan, reviewing the floor plans, reviewing the building elevations, all of these areas that I'm mentioning here, but it's worthwhile going through the steps. This information, understanding this at a reasonable level, takes time. You don't understand like a building like we just looked at by looking at it for a couple of hours. It takes days and weeks to really become familiar with the information and know where you got to look for things. If you understand the basics like the specifications and the coding, you'll know which divisions to look under. You'll get comfortable with that, and that's the nice thing about it being standard. You can know where you need to look, but you still have to become comfortable with the content which is specific to that project, and you have to be comfortable enough to identify errors, omissions, scope gaps, and that takes time. So people like to throw drawings in front of me and think that I'm going to know this drawing intuitively in a matter of minutes. I might know my way around roughly, but it takes me days, and it can take weeks depending on the complexity and what I need to know about the particular project. When we were building e-building, it took me quite a while to get a grasp of everything that was involved with e-building, and then to try to be ahead on the things I needed to know working as a facilities project manager for technology, what I needed to know to ensure that that project met our requirements, George Brown's requirements. So there was a number of things that you have to do, and you kind of look at it, you develop sort of a process, a system of how you look at drawings. And like I may have mentioned before, I have a vision for a project, whatever my responsibility is, and I try to see how my responsibility fits in with the whole project. And I try to visualize what this project is like when it's done, how it is being used, who's using it, how it's being used. And then I try to work backwards from that, shedding things so that I can see, okay, so I know this is a, there's drywall in the walls. What's behind the drywall? Okay, so there's reinforced concretes, or there's metal stud partitions. Okay, there's a curtain wall on the outside. We have a membrane roof system on the top with a green roof. I'm deconstructing it in my mind, but it's helping me to understand everything that's involved. And then I'm really sort of thinking about the aspect of breaking it down into areas of work, which we'll talk about, and you'll talk about too in other areas. But if I'm thinking about breaking it down, I can then take a project and I can break it down into areas of work. So like construction as a heading, pre-construction as another heading. This is just a very short, easy enough project. But site mobilization, substructure, and under substructure, utilities. And then I got slab on grade, superstructure, exterior finishes, building systems, interior finishes, flooring, building systems, right? So these are all areas of work. And then under each area of work, I can come up with what needs to be done under that. And under each area of work, I will have an understanding of who needs to do it. And I can contract that work with them. And I can also cost out those particular areas of work. So I can see how that's costed out for site mobilization. I can see how the building systems is costed out, and then what the various areas in the rough-in stage is. I can actually slide over, I can go to my resources, and I can check my resources, and I can check the costs that I've applied to my various resources. So I can see the total costs on the project that I've applied. So if I start with the construction documents, and I have the engineering drawings, I have the structural drawings, I have the specifications, and beyond that, the other drawings that I mentioned, landscape drawings, mechanical building systems, and I start to separate the work into smaller components. Like at the beginning, it's like, wow, this is this big thing. And if I can start to separate it out, we call this a work breakdown structure, into areas of work, I can keep breaking it down further and further if I need to, so that I can then figure out what I need to do. And nobody knows everything. So then I can consult with the various subcontractors and pull that information. We talked about communication. I'm pulling and extrapolating that information from these subcontractors, suppliers, etc. And that's helping me to figure out, can I do this at the same time? Can I do these activities concurrently? Do I have to do them sequentially? Then I can start working on things like, how long is this going to take? How long is this particular activity going to take? What's my time frame for permits, right? This is 20 days. It could be 10 months. It could be 2 years, if I've got zoning changes and other things that I have to do. So I can take this step by step by step, and I can start to pull together a project plan. And if I start to do that and sequence and procure the work, then I can put a timeline on it and develop a schedule. So this is, but I need to have the drawings, I need to have the specifications and documents, because how else am I going to do this? So this is the fundamental basis for doing this other area, all these other areas of work that I was mentioning. So you really do have to become comfortable with it. And that'll help you, as I just mentioned, with crew assignments and who's doing what. You know, like I could be over here and I could be, if I've applied the data into some sort of management program, then I can source the data. If I haven't, or I've done it willy-nilly, then what I'm looking at isn't good information. So the best of companies have systems that help their people so they can track the data, they can manage it, they can benchmark it, they can look at variances, and they can look at how they can recover things, because things never go exactly as planned. But we need to know where we are at different stages of work so that we can track how we're doing in that aspect. So I'm going to click on the which one was I going to? Resource sheet usage. So resource usage, then I can go by whatever the resource is. I can see what I've assigned for my laborers. Actually, better probably to go to a subcontractor and scroll to task. So subcontractor is what I've applied. So the HVAC sub, what I've applied cost-wise to them. And by activity, so I can check the various activities. I can go to that and see whatever costs I've assigned for those various activities. Some places I maybe didn't assign a cost. Others I probably did, because maybe they're helping and they're not necessarily assigned to it. If I go to, I think network, drain, sub, excavate, concrete. Concrete's a good one. So if we go to concrete, there's a bunch of costing. So it's broken. This is what the forming sub is supposed to do. And then looking at these are the costings that assigned, but also going back to the slide, it can also help us, I'll go again, chart. It can also help us in determining the flow of work and the durations. And if we're saying we're going to form the footing in 3 days, how many people do we need on site to form this in 3 days? Do we need, this is a very small project, I think it's like just under $1 million. So I've got form footings, a concrete forming sub, 3 days. So does that mean I need 2 laborers? Does that mean I need 3 laborers? So that's dependent on preparing crew assignments and ensuring that the timeframes that you've worked out with your subcontractors meet and represent the timeframes you've scheduled for, so that you can meet critical dates for your clients. Because in your contract, going back to the construction documents, you might have a liquidated damages contract that says if your project's late, every day that you're late, it costs you $10,000, $20,000, whatever that is. Well, you want to make sure you're not going to be late, so you got to be very careful about your crew assignments. So it can be very useful for problem solving. It can be referred to for clarifications. We're going to look at that in our case study that is in the textbook, the Construction Site Management textbook, which is an excellent case study. And it's on page 66 if you have the textbook version. But if you don't, it's at the end of chapter 3, and it's called Example 1 under Problem Solving. Gives a good example of how we utilize the documents where there's potential for disagreement. So to wrap up, I'm hoping this gives you a good understanding of how construction documents work, sort of the hierarchy of them, what's typically used. In Canada, we use CCDC, Canadian Construction Documents Committee contracts. In the US, they use AIA construction documents and AGC construction contracts, typically. So you can see some of they kind of roll the same way, but CCDC have been proven, as we mentioned in the previous, a couple of lectures ago. So we've looked at advertisements and invitation to bid, RFPs. We also looked at instructions to bidders, bid forms, certifications, general supplementary conditions, additional information to bidders, addendums, technical specifications, master format, drawings, how that integrates the different types and how they work together, and how we start to pull information out from it. We've even talked about a little bit about cost codes and how that's applied. So hopefully this is giving you a good picture of the documents, because I'm not sure that you've seen that necessarily before and how that comes together. And I'm sure when you're practicing that in your applications, it will start to come together in a lot more positive way. But the information is important, and the better that you learn how to read and interpret these documents, the better PM, project manager, site super, estimator, project coordinator that you will be. It's not good when your subcontractor or your consultant knows the information better than you do. It's very good when you know it better than them. And if you do know it better than them, you want to share that information with them to make sure they don't do something they shouldn't do. And that keeps you in proactive mode instead of reactive mode. So, Tom Stephenson signing off for today. Have a wonderful day, and we'll see you soon. Bye for now.